Welcome back. This video is part of the Getting to Know Cimatron NC series. Today I'll be discussing the automated drill process. Automated drill has three basic functions. The first is to group holes together that are the exact same size and shape. The second is to build, contain, and store drilling sequences. And the third is to automatically fit or match saved sequences to grouped hole geometry based on ranges the user allows. I'll begin with the simple part with the counterbore cap screw hole to show the process of creating a sequence and adjusting some ranges. I'll jump forward to creating the drill procedure. From the guide on the left, I'll start by selecting the Group Manager icon. Instantly, the system offers me the option to select part faces to be considered. The faces will be used to determine the hole geometry and will be considered for gouge protection. I'll choose Select and box pick the part. Then I'll exit with the middle mouse button. The next step is to select the actual hole or holes I want to machine in the procedure. Again, I'll box pick the part and hit my middle mouse button. Notice on the right of the screen I have a single group with a single hole. The next step in the process is to build the sequence for the hole. I'll double-click the group to begin the process. The system is now ready for us to choose the tools for the process. Notice the system displays the geometric hole data at the top left of the screen. The left middle is the cutter sequence data, and the lower left contains the parameters for the highlighted tool in the list. I'll choose New Cutter and select a 1/2-inch diameter spot drill from Cutters and Holders. Notice the anchor flags on the holes. From the top, notice the ST anchor. This is the stock point. It represents the highest level of stock above the hole diameter. In this case, I have defined the stock with a positive 20 thousandths offset. Each of the anchors may be selected to represent the start or stop point of the cutter. I'll right-click on the ST point and select Set as Top Reference. Next, I'll right-click on the DP point and choose Set as Bottom Reference. Finally, I'll set the bottom type as chamfer diameter and enter the desired chamfer diameter for the hole. Next, I'll choose New Cutter and select the 9/32 drill from Cutters and Holders. This time I'll set the DP anchor as the top reference and the BT anchor as the bottom reference. I'll choose the bottom type as full diameter and adjust the delta to push the drill through an extra 50 thousandths. Next, I'll select New Cutter and select the counterbore tool. I'll set the DP anchor as the top reference and the B anchor as the bottom reference. I'll add a top delta of 3/8 of an inch to allow for the pilot of the counterbore, and I'll set the bottom delta to 0. The next step is to define the ranges for the heights. I'll set the range for the stock height between 0 and 1/4 inch. I'll set the range for B between 200 thousandths and 1 inch. And I'll set the BT range between 200 thousandths and 3 inches 425 thousandths. I'll set the option for C to NA. Next, I'll name the sequence and save it to my sequence library. So in conclusion, this seems like a very slow way to drill a hole with the counterbore, or at least to me it did. I'll save and calculate the procedure. Next, let's open a new file, a support plate with some 1/4-inch counterbore holes and some clearance holes for some ejectors. I'll start by creating a new automated drill 3x procedure. Then I'll use the group manager to select a plate and then the holes just as I did in the simple part. This time, before I create any new sequences, I'll ask the system to autofit the hole geometry to the sequences I have in the library. The system located and attached a single sequence to the counterbore holes in the plate. Notice the system used the anchor BT to define the bottom depth of the 9/32 hole. The ranges were set to allow the sequence to drill and counterbore the hole, if the hole depths were within the present standards. The user has the ability to open the ranges for any of the data fields to allow for minor design variations. Users have options to control tool ordering based on each tool or by each sequence. The hole ordering can be controlled as optimized or as user-defined by a preferred X path, Y path, or by selection order. The procedure can reference the previous stock model, and it can update remaining stock based on the tool motions. It gouge protects the tool holder during the calculation, outputting an alert if the holder contacts the stock of the part, forcing the user to address the situation prior to final calculation. For 3+2 users, a 5-axis automated drill may be used to combine more drilling into less procedures. I'll open the simple part with holes on different angles, then I'll go through the familiar process with the group manager. Notice the system grouped the holes. Then with the autofit function, it applies the sequence to all of them. Let's simulate this procedure for a little more clarity. Thanks for watching. Be sure to check out all of our other videos.